All right. This whole chapter is devoted to quadratic equations. And functions. A quadratic equation looks like this. That's a quadratic equation. It's set equal to 0. Because anything other than linear equations, has to be set to 0 before you solve it. All right, so we know this is quadratic because the largest exponent is 2. We call that the degree. If the largest exponent is a 3, then we call it a cubic. If it's a 4, it's a quartic. Anything after that, we just give it a number. All right, this is in standard form. Standard form of quadratic equation. A, B, and C are integers. They could be positive, they could be negative, and they could be 0. All except for A. A cannot equal 0, because if A equals 0, then we have a linear equation, mx plus b. So solving quadratic equations, we'll call these QEs, quadratic equations. If you have 2 terms, it could look like this, or it could look like this. If you only have 2 terms, then remember you have to have the a. The x squared has to be there to be quadratic. Your other term can be the middle term that has an x, or it could be the constant. Depending on which ones you have will make you use a different method. If you have both terms have x, then factor out an x. And then solve both parts. Because if you factor out an x, for example, then if we had this, then we'll have ax plus b equals 0. We have 2 parts. Set them both equal to 0 and solve. If you have 2 terms and only one term has the a term is the x squared's there, then we have to use the square root method. The square root principle says this. If I have a term that's squared, x squared equals some number a, the way you get rid of the square is by square rooting both sides. because the square root and the square are inverses. They cancel each other out. So those cancel out. And what you're left with, it could be a positive or a negative of that square root of the answer. Example, if x squared equals 4, we square root both sides. The square root and the square cancel. Then it's going to be a plus or minus square root of 4 is 2. Because 2 squared equals 4, that satisfies that. And negative 2 squared also equals 4. So it could be answer could be positive or negative. Also, the degree tells us we're going to have 2 answers. And we'll have at most 2 answers. So if you have only one x term, then separate move the constant term to the other side. Get rid of any coefficients that may exist. And square root the number. So the square root and the square cancel. We have a plus or minus negative c over a. That's so let's look at some examples of both of those. We only have 2 terms, they both have x's. So what do they have in common? They both have a 2 in common. And they both have an x. So I can factor out a 2x out of that equation. Now, to determine what goes inside here, since I factored out a 2x, I divide both of these by 2x, and whatever's left goes inside here. So the 2's cancel, and one of the x's are gone. The plus sign. 8 divided by 2 is 4, and the x's cancel. So there's my factored form. So whenever you have a common factor you take out, both of these have the same factor, to see what goes inside there, just divide both of those by what you factored out. Then set both of those equations equal to 0, because it has to equal 0. So x is 0. And x is negative 4. So those are the answers for that equation. Of course, always check your answers. So 2 times 0 is 0, 8 times 0 is 0, 0 plus 0 is 0. Bam. Negative 4 squared is 16. 16 times 2 is 32. 8 times negative 4 is negative 32. 32 minus 32 is 0, so that both of these answers work. So there's the example of the first form. An example of the second form. Two x squared minus 8 equals 0. We have to get rid of anything plus or minus that's added or subtracted to the x. So we have to add 8 to both sides. So 2x squared equals 8. We have to isolate the x squared, so we have to get rid of the 2. Divide both sides by 2. X squared equals 4. Square root both sides. The square and the square root cancel. Since I square rooted a squared term, it becomes a plus or minus. Square root of 4 is 2. Let's see the way I had it originally written. Okay, so we have to get rid of the 8, so we subtract 8 from both sides. 2x squared equals negative 8. Divide by 2. X squared, 8 divided by 2 is 4. Impossible. There's no solution, no real solution. Because anything squared can never equal anything negative. Negative 2 times negative 2 is positive 4. Positive 2 is positive 4. So what you're going to have, if you remember, it's if we square root both sides, then we have a negative, so we have an imaginary term. We'll have a plus or minus because it's square root of squared. Square root of 4 is 2. So our answer is plus or minus 2i. We have imaginary answers. Okay, so that's the first one. That's if we only had 2 terms. If you have 4 terms, if you have 4 terms, at this stage of the game, there's only one method we can use. Grouping. The method of grouping is take the first 2 terms, put them in parentheses. Since the middle term is a plus, you don't have to include it. Just put the second 2 terms in parentheses. Place parentheses around first 2 terms and second 2 terms. Second step, factor both sets of parentheses. So what do these 2 have in common? They both have an x squared. Since we took out, this one has 3, this one has 2, so they both have two x's in common. So if we take away 2 x's out of both of these, you had 3, you took away 2, so you're going to have 1 x left. X squared divided by x squared is 1. In the second one, what do they both have in common? They both have a 4. So if you take out a 4 out of both of these, the 4's cancel, so you have x. 4 divided by 4 is 1. So that's the first step. Factor again. because we have two terms. We have one term here, one, they're separated by a plus. What do they both have in common? They both have an x plus 1. And basically what it says is place the coefficients inside their own parentheses. So take the coefficients and put them inside their own parenthesis. And then solve. When I say solve, set them equal to 0. So subtract 1. So x equals -1. This is two terms, only one x, so we separate them. So x squared, move the 4 to that side, equals -4. Square root both sides. The square root and the square cancel. So I have to put a plus or minus over here. There's a negative inside the square root, so that's an I. Square root of 4 is 2. So the answer is plus or minus 2i. So you only have one real answer and two imaginary answers. And that's going to be another important factor. Whenever you have imaginary answers, they always come in pairs. They always have to come together. Remember, we're supposed to have the degree is 3, which means we're going to have at most 3 answers or 3 solutions. Let's look at another one like that. So we have 2x cubed plus 4x squared minus 4x minus 8. Yeah, we have 3 terms, so we have to use the grouping method. Take the first 2 terms, put them inside parentheses. Since the middle term is a minus, since the middle sign is a minus, include it in the parentheses. If it's a plus, you don't have to include it. Now factor. What do these two have in common? They both have a 2, and they both have 2 x's, x squared. 2x squared, 2x squared. So the 2's cancel. 3 x's take away 2, only have 1 left. Four divided by 2 is 2, x squares cancel. And on the second one, they both have a negative, so take out the negative. Well, we have to take out, whenever you have that, whenever the middle sign is negative, factor it out, which means you have to change both signs inside there. And they both have a 4 in common. So I divide both of these by -4. Negative and negative makes it a positive. 4's cancel, so just x. Negative and negative makes it a positive. 8 divided by 4 is 2. What's important is whatever's inside the parentheses, you want them to be the same. Because in this first term and the second term, we have to factor out what's the same. They both have an x plus 2. Since they both have an x plus 2, we put whatever is in front of the coefficients, whatever is in front. We put those inside there. Yeah, since these are the same in both of them, we factor it out. If we factor them out, what we're left with is x squared minus 4. Now we'll set these equal to 0. And solve. So x equals -2. Only one x, so this one has to go over there. 2x squared, add 4 to both sides. Divide by 2, so x squared equals 2. Square root both sides. So that means I have to put a plus or minus. Square root of 2. And those are my 3 answers. My 3 answers are 2, negative square root of 2, positive square root of 2. How do I know I'm supposed to have 3 answers at most? Because the degree is 3. That means that I have at most 3 answers. All right, so that's what you do if you have 4. You have to try to use the grouping method. If you have 3 terms, which is our traditional quadratic equation, we can either factor it, use the square method, or the quadratic formula. And remember, the quadratic formula is -b plus or minus b squared minus 4ac over 2a, where we only use whatever's in front of the x's, the numbers, and their signs. So let's look at, I'm going to use one equation with all 3 of these methods. And then we could see about finishing up this chapter. All right, here's our example. We're going to factor first. Factoring is we're going to jump straight into put them in these parentheses. So what makes x squared? X and x. Second, look at the second sign. If it's a plus, that means both signs are the same. They're whatever the first sign is. Since the first sign is a plus, they're both pluses. If that was a minus, they'd both be minuses. Then we have to look at what times what is 8. When you add them, you get 6. 1 and 2, or 2 and 4. Then you take both of these, set them equal to 0, and solve. Again, once you get in parentheses, it's always the opposite sign. Those are your answers. So that's with factoring. Okay, let's try another one, factoring that has a leading. So far, if its leading term is 1, then it makes it much easier. So let's look at one that doesn't have something that simple. Let's look at this one. So this one is if A equals 1, if your leading term is 1, try to do it this way. If your leading term is not equal to 1, in this case, it's 10. We're still going to, since we're using factoring, we're still going to use that method. So whatever number's in front of here goes in the first spot. And since it's an x squared, they both get an x. The signs, do the same thing with the signs. Since the second sign is a minus, that means they're opposite. One's a positive, one's a negative. And since they're opposite signs, the bigger number gets the first sign. The bigger number, when we factor these things, gets the plus. Only they get the plus only because the first sign is a plus. If that was a minus, then the bigger number would get a minus. It's whatever the first sign is. Third step, take the first number and the last number. 10 times 9 is 90. Multiply them together. Now what we have to do, we have to figure out what times what is 90. Says minus. That when we subtract them, because that's a minus, that's a subtraction, it has to equal the middle term, 9. So multiply the first and last term, gives me 90. Since the second sign is a minus, I figure out what times what minus what equals the middle term. This is the hardest part. So we have 10 times 9 equals 90, but 10 minus 9 is 1. That's not going to work. How about 15 times 6 is 90. 15 minus 6 is 9. That's the hardest part right there, is try to figure out what two numbers fit in these boxes. 15 times 6 is 90. 15 minus 6 is 9. Again, it doesn't matter what the sign is. Since they're opposite signs and the first sign is a plus, that means the bigger of these two numbers gets the plus. So this one's 15. This one is 6. And take the first and last term, multiply them together. We figure out what times what is 90. When you subtract them, that's the second sign, equals the middle term, 9. Now, with both of these parentheses, factor out what they have in common. In the first parenthesis, what do they have in common? They both have a 5 in common. So remember, whenever you factor anything out, it's the same as dividing. 10 divided by 5 is 2x. 15 divided by 5 is 3. What does the second one have in common? They both have a 2 in common. So to figure out what goes inside the parentheses, since I factor out a 2, I divide these by 2. 10 divided by 2 is 5x. 6 divided by 2 is 3. Whatever you factored out, just delete it. Erase it. Delete it. And there you have it. That's the factored form. Set both of these equal to 0. Okay, here's a shortcut. Whenever you have a binomial that has A and B terms, the answer would always, first off, opposite sign what's in there. So that's a positive, the answer would be negative. It'll be whatever the constant is divided by the coefficient. It's always going to be that way. So as for this one, I'm saying the answer is going to be, so that's a plus, it has to be negative, the constant over the coefficient. Let's see. Subtract 3 from both sides. There's the negative 3. And divide by 2. And there's the negative 3 over 2. So you can, if you don't see that, then just do it the long way. Opposite sign, that'll be positive 3 over 5. These are my answers. All right, let's look at complete the square now. Because we went over these last time. I'm just reviewing really quick. In complete the square, the first thing you have to move is the constant term. How do you get rid of the 8? You subtract 8 from both sides. So we have negative. Move the C term. That's your first step. Second step. Add B over 2 squared to both sides. What's B? When we say B, we're talking about the coefficient of X. Just the number, doesn't matter the sign, because when you square it, it always becomes positive. So what we have to do is we have to add 6 over 2 squared to both sides. Third step. Left side, only do inside the parentheses. The right side, work it out totally. So inside the parentheses, 6 divided by 2 is 3 squared. Don't square it because you'll have to unsquare it later on. 6 divided by 2 is 3. 3 squared is 9. 9 minus 8 is 1. You've just completed the square. Because we set up this equation for the fourth step. The left side in the left side, we're going to put it in the parentheses squared. We're going to take this entire equation and cram it in there. The way you do it, the reason we didn't square these numbers is whatever's under the squared goes inside here, because that's squared. And the first sign. So we have x plus 3. So it's whatever's under the squared and the first sign goes inside there. At this point, we can do two things. We can, one, find the vertex or we can find the x-intercepts, the solutions. At this point now, when we have it written like this, we could do one of two things. We could either find the vertex or we can go ahead and solve it. Let's look at both of them. Remember, when I say solutions, I'm meaning x-intercepts. So let me write this equation out. X plus 3 squared equals 1. X plus 3 squared equals 1. If you're asked to find the vertex, set it equal to 0. So we have to subtract 1 from both sides. And the vertex is the opposite sign of this first one. So that's a plus 3. So the answer is -3. And whatever that one is. It's the opposite of what's inside the parentheses and whatever on the outside is. And there's your vertex. So we've found the highest or the lowest point of the graph. All right, now if we're solving it, then we go on further, because when you solve it, you want to get x by itself. So what you have to do here is square root both sides to get rid of the square. And remember, whenever you square root something that's squared, you have to put a plus or minus in front of the answer. Whenever you square root a squared term, you have to put a plus or minus in front of the answer. So the square root and the square cancels. We have x plus 3 equals plus or minus. Square root of 1 is 1. Now solve for x. So x is equal to -3 plus or minus 1. Those are my two solutions. I have two solutions because of that plus or minus. I use the plus side there and use the minus side there. So we have x equals -3 plus 1 and x equals -3 minus 1. I'll take one of each of these. 3 minus 1 is 2. Since they're both negative, add them. These are my x-intercepts, -2 and -4. Right? So that's complete the square method. It serves two purposes. We can find the vertex halfway through, or we can find the x-intercepts, or both. Now, if you're just asked to solving it, if you're asked to find the x-intercepts, the quadratic formula will always work. The quadratic formula is just that. Remember, we have a quadratic equation. Whenever you use this formula, you're always solving for whatever the middle x is. As long as your equation is of this form, ax squared, in other words, here's what you're looking for. Whatever the middle term, the middle x is, as long as the first x is squared. Whatever that one is, as long as it's 2 times as big. So if the middle term, if we had 2x to the 4th, what would this x here have to be?
Second to the square.
No, see, this one here is 1. There's only one right there. How do you get from 1 to 2? Multiply by 2. So if that's a 4, this one would have to be an 8, because you have to multiply by 2. If it's in that form, then you could use the quadratic formula. As long as the first x is 2 times bigger than the middle x, then we're in good shape. Then we can use this formula. This is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And if you're only asked to find the x-intercepts, this is the easiest formula, but it's always going to work. The factoring only works if it's factorable, if it's easily factorable. The complete the square, if you have a middle term that's an odd number, then you have fractions, because you have to do b over 2 squared. But this one here, your steps here, find A, B, and C. So what is A? A is 1. Remember, because A is the coefficient of your x term. Since x is here, there's a 1 there. What's B?
6.
6. And C?
8.
Yeah. If it was negative, then use the signs also. So since these are positive, we're okay. When you solve these for your homework, always start off, after you label A, B, and C, start off by writing the formula so it helps you memorize it. Write down the formula first on each equation. So I have negative. What's B? 6 plus or minus B. B is 6 squared minus 4 times A. A is 1 and C is 8. Just plug them in there. Over 2 times A. A is 1. Now work it out. Order of operations. Okay, that's a negative 6 in front. Can't do anything there. Inside the radical, 6 squared. 6 times 6 is 36. Negative 4 times 1 is negative 4. Negative 4 times 8 is 32 over 2 times 1.
Did you do negative 4 times 1 first, or?
Yes, because no, I did the 6 squared, and then since that's 6 squared, I could do all these together. So I did negative 4 times 1, and that gives me negative 4. Negative 4 times 8. Or I could do 1 times 8 and negative 4 times 8. But yeah, it's you do those in 2 separate parts.
Okay, thank you.
That's a good question, actually, because I went pretty quick there. 36 minus 32 is 4. Negative 6 plus 1. So the square root of 4 is 2 over 2. Since this came out, we can now solve both of these. We have negative 6 plus 2 over 2 and negative 6 minus 2 over 2. We have a plus or minus for taking into consideration. and we work them out. 6 is bigger than 2, it's negative, so the answer is negative. 6 minus 2 is 4. Negative 4 over 2 is negative 2. They're both negative, so the answer is negative. 6 plus 2 is 8. Over 2 is negative 4. So these are my x-intercepts. Let's look at the second one we did. It was 10x squared plus 9x minus 9. First step is label A, B, and C. What's A? 10. It's whatever's in front of the x squared. B is 9. It's whatever's in front of the x. And C is negative 9. It's whatever the constant is. Write down the formula. And plug and play. So it's negative. What's B? B is 9. B 9 squared. 4 times 10 times negative 9. So negative 9. Inside the radical, 9 squared is 81. If a negative and a negative makes it a positive. 9 times 4 is 36. 36 times 10 is 360 over 2 times 10. Negative 9. 81 plus 360 is 441 over 20. And one trick we could look at 4, what makes up 441? What times what gives us 4? 2 times 2. What times what gives us 1? So 21 times 21 is 441. So square root of 441 is 21, since it multiplies twice. There's a plus, there's minus. So negative 9 plus 21 over 20. Negative 9 minus 21 over 20. Because I have to take positive and negative. 21 is bigger, so it's positive. 21 minus 9 is 12 over 20. They both have a, oh, let's do simple. They both have a 2 in common. So 6 over 10. Well, they both have a 2 in common again. 3/5. So the first solution is 3/5. They're both negative. 21 plus 9 is 30. 30/20. Cancel out the zeros. So we have negative 3/2. Those are my two solutions. Again, the quadratic formula always works. Again, what do these two numbers represent? Those are my solutions. Yes, they represent the x-intercepts. Where the line crosses the x-axis. That's where your graph crosses the x-axis. All right. Let's look at graphs. That's how you solve those things. Let's look at graphs. This is section 3 now. Analyzing graphs of quadratic equations. When we talk about analyzing graphs, we have a quadratic equation. We're going to look for three primary, actually, let's look at four things. We know the y-intercept. What's the y-intercept in this equation? The y-intercept is always the constant. It's 0c. The constant is always your y-intercept. Because how do you find the y-intercept? Set x equal to 0 in order to get rid of all the x's. What you have left is your y-intercept. So that's your first one. Second, we can find the x-intercepts. By solving, either factoring quadratic formula or complete the square. That will give you your x-intercepts. Those are those locations. Third, we can find the vertex. If your equation is given in vertex form, then the vertex is simply equal h, the values of h and k. Vertex form. Vertex form is like this. That's the vertex form. So if I had x minus 3 squared plus 2, what would be my vertex? It's whatever's inside here. It's the opposite sign of that and this number. How about that? What's my vertex? Opposite sign, so it's -4, and whatever that is. If it's not given to you in if your equation is given in standard form, then you can use complete the square to put it into vertex form. Remember, we did that earlier. When I told you when we did the complete the square, we can do two things. We can either solve it or find the vertex. Or you can use the formula for the vertex. The formula of a vertex is -b over 2a that's the x value of it. Whatever you get there, plug it back into your equation, and that will give you the y value of the vertex. Remember earlier, we had this equation. We worked it out using complete the square, and I said we could either solve it or find the vertex. We went and put it on one side, said equals 0, and there's the vertex form. We found the vertex is -3, 1. That's going through the complete the square method. Or we know the vertex is -3, -1. Or we can use the formula. X squared plus 6x plus 8 equals 0. Find the vertex. So we have to label A, B, C. A is 1, B is 6, C is 8. The coefficients. So the x value of the vertex is negative b over 2a. Negative b is 6. 2 times a is 1. So negative 6 over 2 is negative 3. So there's your x value. What this says is once I find the x value, I plug the x value inside the equation and work it out. So negative 3 squared plus 6 times negative 3 plus 8 equals some number. You see, we have to look at it that way. So when x is negative 3, negative 3 squared is 9. Positive times negative is negative. 6 times 3 is 18. Plus 8. 9 plus 8 is 17. 17 minus 18, 18 is bigger, it's negative. 18 minus 17 is 1. So the y value is negative 1. So my y value is negative 1, which is exactly the same thing we got last time. Again, you can choose whatever method you want. There's only one answer. Here's an important thing. The x value of the vertex came from the quadratic formula. The x value of the vertex is called the axis of symmetry. What does that mean? Why is it called the axis of symmetry? Because if we put a dot at the vertex, we also worked out earlier what the x-intercepts were, -2 and -4. 1, 2, 3, 4, 5, 6, 7, 8. And 8 of our equation on the y-axis is the y-intercept. Because remember, our equation was, this is our function. So there's our y-intercept. The reason this is called the axis of symmetry, because if we drew a vertical line through that point, this side of the graph has to mirror this side. If we go from here to the right up, we get a point. If we go to the left up, we get a point. We went 1, 2, 3, and all the way up to 8. 1, 2, 3, all the way up to 8. We have another dot. So we have the mirror image. That's the reason it's called the axis of symmetry. The axis of symmetry is -3. X equals -3. If we look at the shape of the graph, it's opening upwards. We knew that was going to happen from this equation. if A is greater than 0, the graph opens up. If A is negative, if it's less than 0, it opens down. So we can tell just by looking at the equation whether it's going to open up or down by looking at the leading coefficient. If whatever's in front of x squared, if it's positive, we know the graph will be pointing up. If x squared has a negative coefficient, then it opens down. Again, that's without doing any work. If it opens up, if A is positive, then the vertex is called a minimum. The vertex is the lowest point of the graph if it opens up. If A is negative and opens down, that means our vertex is the highest point. Therefore, it's the maximum. Now, will we always have 3 or 2 solutions? No. Quadratic equations can have at most 2 solutions. 2 real solutions. By real, I mean that they're from the real numbers. They're either going to be decimals, fractions, or integers. So our graphs can look like this. So a quadratic equation can have 2 solutions. Those are the x-intercepts. It can have only 1 solution. Or it can have no real solutions, meaning it doesn't cross the x-axis. Those are the 3 possibilities that can occur. Now, how do you know? Remember, to find the solutions, we have to use the quadratic formula. Something inside there tells us whether we have 1, 2, or no solutions. This part right here. called the discriminant. If b squared minus 4ac, if that number, whatever's inside the, if it's positive, if it's greater than 0, we'll have two solutions. Why would he give us two solutions if that's positive? Let's say this equals positive 4. We take the square root of 4, we get 2. Then we have a plus or minus. Those are our two solutions. If b squared minus 4ac is equal to 0, then we're only going to have one solution. We're only going to have one x-intercept. Look at it. If that is equal to 0, what do we have left? Negative b over 2a, only one number. So that is negative b over 2a. That's the one solution you're going to have. And if the discriminant is less than 0, if it's negative, then we're going to have no real solutions. Because if it's negative, then we'll have imaginary. We're going to have two imaginary. So no x-intercepts. So far, so good? So if you're asked just to tell me how many solutions you're going to have, you just do the b squared minus 4ac. Now, where have we seen this before? Yeah, on the vertex, negative b over 2a. Because if your discriminant is 0, all we have left is negative b over 2a. That's the x value. In other words, if it's 0, all you're going to have is one point touching the x-axis. And that's going to be the vertex. And that's going to be the vertex. So that point there is negative b over 2a. Okay, so we talked about the vertex, axis of symmetry. Okay, yeah. In a vertex, the x value of the vertex is the axis of symmetry. That's the x value. Which is negative b over 2a. And then the y value is the highest or lowest y value of the range. So the y value of your vertex tells us the highest or lowest point of the range. So let's look at our original equation was x squared plus 6x plus 8. And our vertex was at -3, -1. What's the range of my answers? Also, what's the domain? Domain, not E. Remember, domain will be all real numbers. In other words, from negative infinity to positive infinity. What's the range? Is this vertex, is it a maximum or minimum? The vertex is a minimum if A is positive. The vertex is a maximum if your leading coefficient is negative. Therefore, if it's positive, it opens up, so we have a minimum point. If it's negative, it opens down, it's a maximum point. So what's our A value? What's A? Is it positive or negative? So A is positive, therefore we have a minimum. So in other words, this vertex is the lowest point of our graph. So the range is all the y values equal to or bigger than -1, since it opens up. Or we can say -1 to infinity. So far, so good. So again, once you find the vertex, look at the leading term. If it's positive, we know we have a minimum. So the range is y is greater than equal to the y value of the vertex. If A is negative, then the range is y is less than equal to the y value. Or y comma infinity, -infinity comma y. Find me the range of these 3 examples. And tell me if it is a max or a min. So is the first one a maximum or minimum? Yep, it's a maximum. Because A is negative, which means it opens down, so we have a maximum. How about the second one, max or min? It's a minimum. Because A is positive, which means it opens up, so we have a minimum. And the last one, it's a maximum because A is negative, it opens down. So what's going to be the range of the first one? Nope, it opens down. It has to go down to negative infinity. So it goes from negative infinity to, or y is less than equal to -2, because it opens down. The second one, here's the vertex, it's going up. If it's going up, it's going to positive infinity. So the smallest range you can have is -2 all the way to infinity. Y is greater than or equal to -2. And the last one, nope. It's the, what's the highest y value? 0. Remember, I just said earlier, where would I put that? Right here. In the vertex, axis of symmetry is the x value. The highest or lowest point of the range is the y value. Okay. So when you graph these things, just plot the vertex, the x-intercept, y-intercept, and the mirror image of the y, and then there's your graph. All right, so that does it for section 3. Section 4. Section 4 deals with rationals and radicals. Solving rational and radical equations. Before we continue, we have to define what are rationals and what are radicals. Fractions. And more so with x on the bottom. Radicals are square roots or cube roots or nth root. It's that symbol. That's a radical. We're going to start off looking at rationals. Since day one of the semester, I've always stressed this rule. If you have fractions and an equal sign, then get rid of the fractions. That's a general rule to live by. Here's an example. We have fractions and an equal sign. So here are the steps. It's always the same 5 steps to get rid of the fractions. First, find the LCD. In our case, what is our LCD? If you can't see it, right, our denominators are 7 and a 3. If you can't see it off the bat, just multiply them together. 7 times 3 is 21. Yeah, don't spend too much time trying to figure out what the LCD is. If you don't see it automatically, just multiply your denominators together. Once you find the LCD, is multiply the LCD to each term. Remember, what is a term? Anything separated by a plus, minus, or equals. So how many terms do we have in our equation? Yeah, we have one term here, one term here, and one term here. So all we have to do when we say multiply the LCD to it is just put it in front. Just put parentheses around your terms and put the LCD in front. Next step. Whenever you're multiplying fractions, never multiply straight across first. Always reduce. Cancel what you can first. So in the first fraction, can anything cancel? Yeah. 3 goes into 21 how many times? 7. 7 goes into 21, 3. And there's no fraction there. This is what we have left. Multiply to remove the parentheses. 7 times 2 is 14. 3 times 5 is 15. X. 21 times 3 is 63. Then solve for x. Combine like terms, solve for x. Since all the x's are on one side, we have to get rid of the 14 by subtracting 14 both sides. (63 minus 14 is 49. Just borrow the one. 13 minus 4 is 9. 5 minus 1 is 4. And divide both sides by 15. (15 goes in 49 how many times? (15 times 2 is 30. 50 times 3 is 45. With how many left over? Very good. So however the computer asks you to put the answer in, that's what you put in there. So whenever you have fractions, get rid of the fractions by doing that. Find the LCD, multiply the LCD, and then get rid of it from there. All right. But x's are not on the bottom there. Let's put x on the bottom. Now things change a little bit. Your steps have now changed. The first thing you have to do, whenever you have equations on the bottom or on top with x's, put parentheses around them, because they have to stay together. You can't split those up. First off, factor the denominators. We need to see what the lowest possible terms are for each one. So that one's as far as you can go. So that one's good. This one's as far as you can go. Whenever you have anything squared, or if you have coefficients in both of them, usually something can factor out. So what do they both have in common? They both have an x. So I take out one x, which will leave me x minus 3 in the denominator. The next step, once you factor out the denominators, solve each, in other words, set them equal to 0 and solve for them. To find out what x's you can't use. solve each of the denominators to find out what x is. Why is that? Why do I want to solve? And then how can that be the ones I don't want? Because anything divided by 0 is undefined. We do not want 0 on the bottom. So what x's would make the bottom 0? We can't use those x's. We can use any other x's of those. So in here, we have x equals 0. We can't use 0. So our final answer is x cannot be 0. X minus 3 equals 0. So x cannot equal positive 3. It's the same in there. So the two x's we cannot use are 0 and negative 3. Now, when we solve the rest of it, whatever is not 0 or 3 will be our answers. So I took each of these denominators, the different ones, I should say, and solved for x. Now, since I have them all factored, now I can do the LCD thing. What's my LCD? X and x plus 3, or x minus 3, I should say. Those are all the denominators. Multiply the LCD to each term. So we have x minus 3 times 3 over x minus 3 times 2 over x minus 3 equals x minus 3 times negative 4 over x minus 3. All right, so once I multiply LCD, what do I do next? Reduce. Whenever you multiply fraction or anything to a fraction, before you multiply them, always cancel first, reduce first. So in the first one, the x's cancel. So I'm left with 3 times x minus 3 plus. In the second one, the x minus 3 cancels. 2 times x. And the last one, they both cancel, equals negative 4. So the whole purpose is to get rid of the fractions. So this is a lot easier to work with. Multiply to get rid of the parentheses. 3 times x is 3x. And positive, negatives, and negative. 3 times 3 is 9. Whenever you get rid of parentheses, always combine like terms. 3x plus 2x is 5x minus 9 equals negative 4. And then solve for x, or solve. Add 9 to both sides. Positive, 9 minus 4 is 5. Divide both sides by 5. X equals positive 1. Is one of the numbers we can't use? No, because we can't use 0 or 3. So this is our answer. And we could always check your answers. Okay. So it's always advisable to check your answers. How would you check your answer? Go back to the original equation, and anywhere you see an X, put a 1. And work it out. See if it works. 3 over 1 is 3. 1 minus 3 is -2. So it becomes a -1. 1 minus 3 is a -2. 3 minus 1 is 2. Negatives cancel. 4 divided by 2 is 2. So it works. Make sense? It's a drawn out process, yes, but it's the best way of solving these things. There are 3 special cases I forgot to talk about. When it comes to factoring. The first one. The difference of 2 squares. What it's saying is, if I had 2 numbers that are perfect squares, and the difference, which means minus, if I have that, then the factored form of this thing is the A and B. So I have A here, B, A and B. One's positive, one's negative. So is that a difference of 2 squares? What is 4 made up of? 2 times 2. So what this is x squared minus 2 squared. So since this is a perfect square, I can write it as that. Which means now the factored form of this is x plus 2, x minus 2. Because these have to be the same number. 2 times 2 equals 4. What's that one going to be? Yeah, 36 is 6 times 6. So the factored forms are x plus 6, x minus 6. It doesn't matter how you put it. You can put x minus 6, x plus 6. They both mean the same thing. How about that? So 5 times 5 is 25. 6 times 6 is 36. So 27 is not a perfect square, but neither is 3. Do we have anything that factors out? Anything in common in both of these numbers? Yeah, we can take out a 3. So if I take out a 3, I divide both of those. So I have x squared. 27 minus 3 is, or divided by 3 is 9. Nine is made up of 3 times 3, so it's 3 squared, which means our factored form, x plus 3, x minus 3. How about this one? 16x squared minus 25y squared. What's 16? Is that a perfect square? Yes. So it's 4 squared. 4 times 4 is 16. What's 25? 5 times 5, so it's 5 squared. Since they're both squared, I could put them under the same parenthesis. Now, since these numbers are both squared, it's going to be 4x, 5y. One's plus, one's minus. So if you can get two numbers or two terms under squares, then you can factor it out that way. So far, so good. How about that? Is 1 a perfect square? What is 1 times 1? Yeah, so in other words, this can be written as this. So it's x plus 1, x minus 1. Because you may be faced with equations like this. So remember, first step is factor. This is as far as it goes. This one's as far as it goes. How about this one? This is x plus 4, x minus 4, because 16 is a perfect square. So what's my LCD? Very good. X plus 4, x minus 4. So I multiply those in front of each term. Reduce, the x plus 4's cancel. X plus 4x minus 4 cancels. And the x minus 4 cancels. So that's what I have left. 2 times x minus 4 minus 3 equals 5 times x plus 4. So, yep, now get rid of the parentheses. 2 times x is 2x. Positive times negative is negative. 2 times 4 is 8. Positive, positive is positive. 5 times x is 5x. Positive, 5 times 4 is 20. Whenever you get rid of parentheses, always combine like terms first. Negative 8 minus 3, they're both negative. 8 plus 3 is 11. Now what do? You have x's on both sides. Which one do you move? Always move small. Yeah. So don't even, when you have x on both sides, don't even look at other numbers. X's are the important thing. So we subtract 2x from both sides. So negative 11. 5 minus 2 is 3x plus 20. Since all the x's are here, we have to get rid of the 20. So we subtract 20 from both sides. So negative 31 equals 3x divided by 3. So x is equal to negative 31 over 3, or negative 10 1/3. But when you check it, it's always easier to check it in proper fractions. What are our x's we can't use? Right, we cannot use 4 or negative 4, right? Perfect. We should have done that sooner, but I forgot. Okay, so that's one of the special factors. The next ones are the sum and difference of 2 cubes. The sum of 2 cubes means this: a cubed plus b cubed. And by difference, I mean a cubed minus b cubed. So if you have terms like this in your equation, the factored form of both of these will look almost identical. The only difference are the first 2 signs. So inside the first parenthesis, it's whatever's under the cubes. A plus B. Inside the second one, it's the first number squared the opposite sign, the multiplication of the two terms, A and B, plus the last one squared. It's the first one squared minus A times B plus B squared. So whatever the first sign is, it's under the cubes. The first sign here is opposite that one. So what goes in the second parenthesis? Second equation. In here, there's this, I'm sorry, yeah, the second set, I'm sorry. Yeah, which whatever's under the cubes. A minus B. And the second one? Mm-hmm. Very good. Very good. And the second one is always B plus B squared. So here's an example. First thing you have to determine, are these two cubes? What is 8 made up of? Yeah, 2 times 2 times 2. Since it's the difference of two cubes, we can split them up. So what goes here? Very good. Next one. X squared, very good. Very good. 2x, because it's these two numbers multiplied together. And set plus 2 squared. So it's going to be x minus 2, x squared plus 2x plus 4. There it is. This, you can solve for this one. It's going to be 2. This one does not have a solution. It's imaginary. So that's why it's 2 separate equations like that. Very good. So those are the factors. You want to do a plus one, or are you okay with it? You want to do one? Okay. Because you said that. There. Is 1 a perfect cube? Yes. So this could be written as 2x cubed plus 1 cubed. So we have 2 cubed. So in the first parenthesis, what goes there? It's whatever's under the cubes. 2x plus 1. Yep. Now it's this one squared. No, 2 squared is what? Well, actually, I'll do it. So it's, since this is one equation, it's 2x squared. What sign? Very good. Then you multiply these two together. 2x times 1 is 2x plus 1 squared. So this one, 2x squared is 4x squared. Why is 2x squared 4x squared? 2x squared means 2x times 2x. 2 times 2 is 4, x times x is x squared. Minus 2x, 1 squared, and there you have it. It just takes practice. I mean, you see the concept here. You've been answering the questions. You see the concept. It's just that it just takes practice to see the numbers and make sure it works. All right, so those are rationals. Let's look at radicals. We're almost done, believe me. Radicals. First off, remember what the graph of this one looked like when we talk about library of functions? Inside there, you cannot have any negatives, and the answer cannot be negative. So the objective here is to isolate the radical first. If you have anything plus or minus or multiply divided to it, you have to get rid of that first. You have to get it all by itself. Equals whatever. How do you get rid of the square root? No, you square but you're very good, very good. Square both sides. So the square root and the square cancel. 2 squared is 4. And subtract 1. And there's your answer. And if you check it, it works. How about that one? Yep, you have to get rid of the 5. So we have square root of x minus 3. 9 minus 5 is 4. Then square both sides. X minus 3 equals 16. And lastly, add 3 to both sides, yeah. Again, if we check it, we have 19 minus 3 plus 5 equals 9. 19 minus 3 is 16. Square root of 16 is 4. 4 plus 5 is 9. There. So far, so good? First step. Get rid of the 4. How? Add 4 to both sides. Four minus 1 is 3. Then what? Very good. Get rid of the coefficient. Divide both sides by 3. Square and square root cancel. 1 squared is 1. Add 2 to both sides. X is equal to 3. Three minus 2. 3 minus 2 is 1. Square root of 1 is 1. 1 times 3 is 3. So it works. Oh, yeah, you're right. I didn't go all the way up there. Yeah, so this part would have been 3. 3 minus 4 is negative 1. I stopped because I had it covered with my hand. If it's what? Oh, if it here? Here? Yeah, it's yes. Yeah, normally they won't give you something like radical 5 or anything like that. They'll give you something that really works out. Okay, let's try this one. Square root 2x plus 5 plus 6 equals 4. Subtract 6 from both sides. 2x plus 5 equals 6 is bigger, negative 2. Okay. Okay, let's see that. If we square both sides, we get 2x plus 5 squared equals negative 2 squared. So those cancel. 2x plus 5 equals 4. Subtract 5. So 2x equals negative 1. X equals negative 1/2. Professor, good? Okay, so let's go back up here and check. 2 negative 1/2 plus 5 plus 6 equals 4. The 2's cancel, so it's negative 1 plus 5. Negative 1 plus 5 is 4. 2 plus 6 equals 4. Does 8 equal 4? No. The reason being because square roots can never equal anything negative. Because of that, it's no solution. Yeah, so even if you don't see it right up here and you work it out and it doesn't work, if it doesn't work out, then you know it's no solution. So that's a second test. If you didn't catch it here, you should catch it here. Yeah, this tells me that there's no solution possible because no matter what you put in there, it'll give you a wrong answer. What if? Ooh, now we have a variable. Uh-oh. Again, same concept. We have to isolate the radical. Subtract 3 from both sides. X plus 3 square root equals x minus 3. Okay, so now what? We have to square both sides to get rid of the square root, right? The right-hand side is one equation. That has to stick together. So I put parentheses around it. So x plus 3. Now, what this means, because it's squared, it's x minus 3 times x minus 3. We have to do the FOIL thingy. So x times x is x squared. Positive, negative is a negative, 3x. Positive, negative, negative, 3x. Negative, negative is a positive. 3 times 3 is 9. So it's x squared minus 6x plus 9. So whenever you have an equation on the right-hand side, you have to square it. Put it in parentheses and square it. And you can't square individual terms. You have to square the whole thing. All right. Since it's a quadratic, how do we know it's quadratic? Because it's squared, which means it has to equal 0. So we have to move everything from the left side to the right side. Subtract x, and I subtract 3. Negative 6 minus 1 is negative 7x. 9 minus 3, 9 is bigger, is positive 6. You could go ahead and try to factor it. If it works, great. If not, you just wasted your time. Or you can use quadratic formula, but this one here, I think will factor. What goes in the first space? What signs do I put there? Look at the second sign. It's a positive. The only way that second sign can be positive is if the signs are the same. And the only way they can be the same if they're both minus. If the second sign's a plus, that means they're the same signs. It's whatever the first sign is. Now we have to look at what times what is 6. When you add them, you get 7. 1 and 6. Yeah, so this one happened to work. If it doesn't work, don't spend too much time. Jump straight to the quadratic formula and it'll work. Set both of those equal to 0. So your answers are 1 and 6. Nah, but that's not our answers. What are we missing? Check your answers. Okay, let's do square root of x plus 3 equals x. Square root of x plus 3 equals x. X equals 1 and x, let's try both of them. One plus 3 equals 1. Anywhere I see an x, put a 1. So when x is 1, it doesn't work. So that cannot be our solution. And we check the second one. When I see an x, I put a 6. So 6 plus 3 equals 6. Square root of 9 plus 3 equals 6. Square root of 9 is 3. 3 plus 3 is 6. So the only answer we have is x equals 6. So far, so good. Once you finish it, always check your answers. Okay, that does it for that section. The last one's even shorter. Section 5 is solving equations and inequalities with absolute values. This is pretty straightforward. So if we had absolute value of 3, what does that equal? If I had absolute value of -3, what does that equal? So inside there, I can put a positive or negative. It gives me the same answer. So in this case, what this is saying, well, let me put a 3 here instead. So if I had absolute value of x equals 3, what can x equal? It can either be positive or a -3, because it can be positive or negative. Which brings us to our rule. If we have an absolute value around our x equals some number, and we drop the absolute value, we automatically put a plus or minus in front of the answer. So this is the formula for this first part. Okay, I have the absolute value isolated equals a number. Now I can drop the absolute values. If I drop the absolute values, I put a plus or minus in front of the answer. Solve for x. I subtract 7 from both sides. X equals -7 plus or minus 5? -7 plus 5 equals -7 minus 5. Equals -2 or -12. So now check your answers. So we have absolute value of -2 plus 7. -2 plus 7 is 5. Absolute value of 5 is 5. That works. -12 plus 7. -12 plus 7 is -5. Absolute value of -5 is 5. That's all there's to it. Again, it's the same thing as you have to isolate the absolute value. How about that one? Absolute value is going to equal negative. No solution. So, yeah, so once you isolate the absolute value and you drop it, just put a plus or minus in front of the answer and work it from there. Now look at inequalities. We have two possibilities here. Greater than or less than, greater than equal to or greater than, less than equal to or less than. Let's define what absolute values really mean. An absolute value, what it really means is the distance a number is from 0. So the absolute value of -3 is what? Yeah, because -3 is 3 spaces to the left of 0. The absolute value of +3 is 3. It's also 3 spaces from 0, just different directions. So it becomes much easier when we look at it as that. Let's look at the less than first. If absolute value of x is less than a, that means it's going the distance from 0 to a. It's going from a down to 0. That means the same thing has to happen from -0, from -a, it has to go towards a. So whenever you drop the absolute value sign of a less than symbol, remember the squiggly line here, those are my x's. In this case, x is between negative a and a. So if you drop the absolute value of a negative symbol, whatever's inside there goes between the negative a and a. Let's look at this one. So absolute value of x plus 2 is less than or equal to 5. The absolute value is isolated, which means I could drop it now. If I drop the x plus 2, what happens to this 5? It's less than 5, but it's greater than negative 5. Whereas whatever's here goes on both sides. We're solving for x, so we have to get rid of the 2. Whatever we do in the middle, we have to do everywhere else. Negative 5 minus 2 is negative 7. Less than equal to x. 5 minus 2 is 3. How would you graph that? There's negative 7. There's 3. Are they open or closed circles? They're closed because they're equal. And x is between there, so now there's a third form we could put it into. This is set notation. We talked about that 2 weeks ago. That's graphing. And the other one is interval notation. The interval notation is you simply take the endpoints, and since they're both closed, they're brackets. That's the interval notation. Pretty good so far? So if it's less than or less than equal to, then you have to put whatever answer it is on both sides. One's positive, one's negative. Now the other side, if it's greater than, which direction is it going? Away from or towards 0? Away from, yeah. So it's going towards infinity. But likewise, since it's going away from, that means the negative side has to be going to negative infinity, has to be less than. So if it's greater than, two things occur. and we drop the absolute value, X can be less than negative A, or X can be greater than positive A. We're going two different directions. So we have X plus 2 is greater than or equal to 5. The absolute value is isolated. It's by itself here. We don't have to move anything else. So now we can drop the absolute values. If we drop the absolute values, then X plus 2 can be less than or equal to negative 5, or X plus 2 can be greater than positive 5. So now we solve both of those separately. Subtract 2 from everybody. Negative 5, negative 2 is negative 7. So X is less than equal to negative 7, or X is greater than 5 minus 2 is 3. So the set notation is X is less than equal to negative 7, or X is greater than equal to 3. Since they're equal to, those are solid dots. X is less than negative 7, so it's to the left, to negative infinity. And X is greater than, solid dot, it's going greater than, so it's going towards infinity. What would be the interval notation for this one? Remember, interval notations always looks where the X's are, and it goes to the beginning and end point. And it's a bracket. Very good. You remember, very good. Excellent. And that's all there is to inequalities. Because yeah, we did it earlier. Only thing you have to know now, if it's greater than, then it's going both directions. It's greater than A to the right, less than negative A to the left. If it's less than A, then it has to be between positive and negative A. That's the only thing you have to remember right here. That does it for chapter 3. Any questions? I need you guys to finish up the homeworks and take the tests, because especially before next week, try to get it before next week, because next week starts chapter 4. And chapter 4 has a lot of moving parts. But once we get over 4, it starts going down much easier after that. Chapter 5 only has like 5 sections. Chapter 6 has 2. 7 has 1. And if we get to 8. All right. So that's it for today. Go enjoy the sunlight before the storms come.